I have found my most beloved pattern in all of Rust in terms of its ability to program and have the syntax. It's like a nice combination of capabilities in the language that combines the enum, enumerations, and the match statement, the match keyword. These two together are the most powerful and my most favorite combination of keywords in all of Rust. And I didn't even know I was doing this, something called destructuring. When I was leveraging this pattern, you can create an enum, right, which is a list of possibilities. An enum, typically when an instance of an enum is created, it's only going to be one of these items, right? It's an enumeration. It's like, okay, one of these items will exist per instance. These are possibilities or states of a system, right? What is the current state of the system? It can be only one of these things at a time. So you can define, for example, here's a set of colors, right? So definition of colors. You could also do like magenta, right? Or yellow, right? So these are common colors. You can also define custom colors with variable amounts of data in a tuple format. Most colors are defined with a U8, so U32 is pretty, I would say, kind of generous. Most colors are defined like this. Okay, now that we have our color enumerator, you can match on those enums like this. Look how readable that is. Isn't that super duper readable? So before, we were also looking at destructuring arrays and tuples. When you do that, you don't really have any labels to assign to it. And so the readability drops a bit. But with enums, you can define the possibilities and then match on those possibilities using the name so you know what you're matching on. In addition, you can destructure the data when some of the information is variable, right? Like red, green, blue. You've got some colors here. In this case, we have an RGB. And also check this out. I love how Rust does this. We added a few additional colors. Rust with the match statement says, uh-oh, warning, you've not covered these cases. You must add them in. It's so good. Let's add those colors in really quick. So we've got magenta and yellow. Here we go. All right, so we added those in. It's such a great pattern. It's like, it holds your hand. Oh, see, no, look, it worked. I was thinking that this might not work here because these are U8 and these are by default U32. It knows that it needs to convert those types because the RGB needs to be this pattern, and it automatically knew the data type because of the Rust inference at the compile time. It's so good. Isn't this a lot more readable? Destructuring the variables like this. Oh, it's so good. I would probably do red, green, and blue, something like that. And then I'd also, instead of passing the data like this into the print statement, I would do it like this. We do green and blue. I like that better. It's about the same amount of syntax and keystrokes, but it's a little more readable. And I don't have to like decode it like, oh, what's this element here? What's that gonna be? I mean, obviously it's hue, but then it's the H variable. And the H variable's here. It's nice. It's like an extra niceness. There we go. Red, green, blue. And because we've defined it in an enum in terms of the variable and the scope and the capability, we have defined all possible arms in the match statement, right? So we don't have to add another arm, this is what an arm is right here. It's like another case, right? Another case for it to occur. So it's really clean. It helps you program over time. It's easy to read. It's lower debt, right? Because it's easier to follow up on. And the compiler helps you a little bit more, right? It's able to catch extra. This is why the enum and the match statement combination is my favorite by far. Now we're getting crazy. We have the ability to destructure our structs. Okay, what's going on? We can destructure our structs in a match statement or any other kind of variable bindings. This is the syntax is starting to get a little crazy here because it's like, how do you even read this? It is remarkably powerful. Don't get me wrong. And it is a better approach compared to just, destructuring and matching statements with an array or tuple. It's a little bit better because it allows you to have some shorthand. So I'd say it's, compared to an enumeration and a match statement, it does not even come close because that is like my favorite and a paramount in terms of code simplicity and easy to follow, easy to read. This is a little more interesting, a little more tricky. But let's walk through this together. So we have a structure here named foo where we have an X and a Y element. X is a tuple with two elements. Y is just the number. We're going to create an instance of our struct by defining the data with a tuple of 1, 2, and Y, 3. So we have essentially two variables inside of our struct. One of them is a list, a tuple, and the other is a number. Now we're going to match that data using the information we know of the struct. So we can match on foo. We know it's going to be a foo struct type, right? We have to to do that. And then we can start getting into the destructuring part. So our X, where the first element of the tuple is 1, and then we don't know what the second element is, but we want to capture that data. We can kind of call it maybe X2, even though it was B. We also want to capture the Y data. So we can print this out, and reading this right here, since X is 1 and it captures the rest in a variable binding through destructuring, this is the first and the only thing that should run. So I should see this output when I run this program. First of X is 1, and then it gives me B and Y. So yes, it worked. Okay, first of X is 1, B equals 2, Y is 3. Okay, so we could ignore the first one. We just took a look at that. All right, so the next one is also possible to match, where we say where Y is 2 and X is I. That's confusing. This is really confusing. I would rather say X is X. I'm pretty sure that'll work. We can say X is X is, oh wait, no, that won't work because that needs to be set there. All right, so we got X is X is X, right? It's gonna give me an error. Yep. All right, now we should get data. Here, perfect. And we don't care about X. We do care about X though. Oh, look at that. Oh, because Y is 3. All right, let's update that. I want to be able to run this function here, or this match. All right, so now I've set Y to 2. There we go. Y is 2, and I, which is not I, it's actually X, because I named it X. Let's try that again. All right, Y is 2, and then X is 1, 2, which is the tuple. Also, X is X. I think you can do this, just like that, right? I mean, because you're doing it here. So why can't you do it here? And you can. Okay, that's really nice. So Rust lets you do shorthand for the element name in the struct. You could just add that in, and then it will become also the variable, probably through shadowing, sort of like the shadowing idea for inner scopes and things like that. So it knows to bind the data to X when you've defined it, the exact same name. So that's really clean. You can also do that here. And then we've got the double dots. All right, so the double dots saying we care about only the Y element in the struct. So we hide this. Now this is the only match statement that should exist. Y is 2 and we don't care about anything else. So there could be other elements, right? We could add X, Y, Z, and then you're only capturing on Y, which is really great. However, you can't do this. You have to do it like this because the structure has more information in it, and the match statement won't be able to match on something like this because this doesn't exist. You need to be able to match on it like this. You can also do this, which I think you have to say that. I think this will work. And these two are essentially equivalent. So if I comment this out, should work. And it does. Okay. So we kind of see here that these two match statements here, they will work pretty much the same. Because dot dot means the rest, and we're not going to assign it to anything unless we wanted to. Can you do it that? You might be able to do that. I mean, we could do it earlier. Let's see if that works. I don't know. It's having a problem. Okay, so this @ symbol only allowed in a tuple or a tuple struct. What? Oh, if the struct is a tuple, which can exist, you can have tuple structs and slices. Okay, so in this case, it's not going to know what, because it's all named data, right? So it won't. It's not a list. It's sort of like a dictionary, right? So you've got specific entries that are indexed versus just elements in a row. So you can't use this pattern. That's good to know. I mean, it makes sense. I understand. Also, you don't need a match statement to destructure a struct. Right? You can destructure your struct using this pattern right here. See, we've got a variable here, which is an instance of foo, and we've defined the data inside. You can also destructure by saying let foo, which is in a struct, we're going to say X is going to equal X0, Y is Y0. And now we have two new variables, which is a little confusing. You're like, what's going on here? Really, these are the variables right here, X0 and Y0. That's the data that's actually getting defined. Everything else is just kind of scaffolding that lets you know where the data is going to be assigned. So this is how you destructure, or essentially extract the data. What if we only cared, I suppose if you only care about just X, right? And you don't care about anything else, and you just want to capture the X data, you can do something like this. And then we should see outside X, which is going to be a tuple of 1, 2. Here we go. X0 equals 1, 2. Happiness. Also, you could just have this a shorter hand than this. This is a little bit verbose. Just to capture one of the elements inside of a struct, you could do just simply this, right? X0 equals foo.x, because we just care about the X element, right? Foo.x. So we have this, and this is identical. These two things are basically the same side by side. This one's a little more easier to read. I see what's going on here. This is, what is this? right? What is happening here? But if you need to just capture one element, that works as well. You could also just directly, I believe, just directly reference inside. Let's see, it should be foo.x, right? Foo.x. Is that going to work? We should see 3 print statements and the compiler should be happy. Not supported in format string. Okay, so you can put it outside the format string. Okay, there we go. So it's happy. So now we've got 3 examples that work for accessing data within structs, including a destructuring. And if you wanted to get really crazy where there's a struct inside of a struct, you can do that too. So we've got another struct here, and this struct has a foo struct inside of it. And so you can destructure with nesting as well. So it's really powerful, and in the scenario where you need it, it's going to be really useful. Very common and often, though, I'd recommend against doing things like this if you can avoid it, because it is difficult to read. It's just a lot of bracket braces here, curly braces, and some colons and some nesting is a lot. It's just a lot.